If you're a developer, you probably heard about the solid principles, and you might have even gotten this as a interview question. It's a very common one. But the problem is there's not so many resources on how do solid principles actually apply to a React code base. So in this video, I'll go through the 5 solid principles, and we will see how we can actually apply them to a React.js code base. And you can use those examples either to refactor the code you are working on or as an answer to interview questions if you get one. As we apply those principles to a React code base, what you'll actually see is that we also come up with different React.js patterns like the presenter container, custom hooks, render props, and app state architecture. And this is a good sign because it means that applying these timeless principles, you can actually come up with patterns. And so we kind of kill 2 birds in one shot because you get to learn both the solid principles and common patterns to apply to a React.js code base. Now, I'm Bogdan, so this person over here, I founded a senior dev 4 years ago with my brother, and together we helped over 300 JavaScript developers get to senior. So of course, solid principles, clean code, and design patterns are a huge part of that. Let's start with number 1, the single responsibility principle. And this is one of the easiest to apply, and it basically states that a piece of code or a class should change because of only one reason. But how can we apply that to a React component? Well, let's take this simple example. We have this user profile component, and it's basically fetching some user data from an API, handling the error and loading state, and then finally rendering that. So if we see the component, it kind of looks like it's really oriented around doing one thing. But if we take a closer look, we see that there's this whole data fetching logic and state management of the data fetch that is completely separated from what painting and showing this to the user is. And so if we were to apply the single responsibility principle here, we can divide this into components and have only one of them fetching the data and the other one painting. This is what we call also the presenter container pattern, where this component will be the container, and then we're going to have a child component responsible of only painting the data. If we were to apply this, this is how it looks like. We have the container, it fetches the data, it handles all the state, and then delegates the rendering to the presentation component, which is a stateless component that just does the presentation. If the product manager comes up with a new requirement for how they should be displayed, we only change this part of the code. If the API changes, we only change this part of the code. So all of a sudden, changes coming from different directions would only affect the piece of code, the component relevant to that change. Another example would be to wrap this in a custom hook. So rather than having a container, the container presenter pattern, you could wrap the fetching in a custom hook. And this is how a component will look like. Again, we're using a single component to do everything, but most of the data fetching logic is contained in this hook. So it's kind of abstracted away. So you could also apply the single responsibility principle like this. By the way, if you are looking to get to senior or you're interviewing right now, make sure you take our free technical assessment. There's a link in the comments. The assessment is built with interview questions, and it will really reveal the different gaps you might have in order to get to senior level. Let's go on with number 2, the open-close principle. What the open-close principle states is that we should be able to alter behavior without just necessarily changing code. Now, how does that look like in React? Well, imagine we have a button component that has a handle click function. In this case, the handle click function is hard-coded. So whenever I need to change the handle on click behavior, imagine I need to send something new to this analytics method. I want to send like some new data. I would have to change the component itself. I would have to change the code of the component. And this is what violates the open-close principle. If we were to implement this in React and make this open-closed, we could actually provide the onClick as a prop. And this would allow us to pass different functions. So we could change the behavior of the button by changing the onClick function without altering the code inside the button component. So to onClick, we could pass this function, which was the one from before, or we could have a different one that also sends maybe the timestamp, or we could add a purchase activity. So we could basically change this onClick function to alter this behavior without changing the button code. That's the open-close principle. The next one would be the list code substitution. And basically what list code substitution mentions is that any child of a parent class should be able to have all the functionality of the parent. This one is a bit complex, and it's really very relevant if you were working with Java. In React, it doesn't make a lot of sense. Why? Because React already solved this problem. One of the main principles behind the React philosophy is composition over inheritance, which means rather than inheriting from a component, we build components by putting them together. Pretty much like you would be assembling a car. You take different parts and you put them together in a higher order part. And this is what already prevents a lot of the problems. So the list code substitution principle, it's already satisfied in components framework like React. So instead of having an inheritance chain, and this would be like, let's say, our final component, and it should, inherit from thousands of components before, which will result in very tight coupling, we actually compose these components into a higher order one, just like you would assemble a car. So if they ask you about the list code substitution principle, don't worry, React already complies with it because React favors composition over inheritance. Moving on to interface segregation, this is another very simple one. Basically, what it states is that if I'm consuming or using a component, I shouldn't be getting more props than I actually need. A good example would be this product card props, where we have all these interface as props, right? We have different props that I need to display a product, but I also have these two to make actions on the product. So I could easily split this, or interface segregation, into a component that will only take, the details to display them, and another component that has the actions. This is, as you see, very similar to the single responsibility, but is very oriented to interfaces we expose. So imagine this would be a reusable component that I give others to use, and they just want to display, for example, the product. It's much easier to split this into two different components, so the clients or whoever is using this only get what they need. They do not get a huge component with thousands of props that they not really use or that are not relevant to their use case. Last but not least, dependency injection. This one is very implemented by backend frameworks, but we can also apply it to React. And this basically states that it's better to pass your dependencies as arguments, in this case as props, than directly importing it. So we have here a app component. It's using a logger, and we make this import to get that logger, which means this is now tightly coupled. We cannot use app.js without having a logger, and we cannot use app.js with a different version of logger. It's always the logger we import. If we were to apply dependency injection and we pass the logger as a dependency injected at runtime, so whenever somebody's using app, they need to pass a logger, we actually have the same behavior with the flexibility that we can pass different objects here. So imagine we are testing the app component, we could pass a mock version of logger and actually be able to write a unit test for this. Whereas here, we somehow will need to override the import and do some very sophisticated logic to provide a different logger implementation. So this example right here, it's a lot easier to test and it's a lot easier to decouple. Finally, how can we actually use Solid when we architect our app? A very common example is when we have React context that we use to store global state, and it's kind of consolidated in a single context. Like in this example, I have an app provider that has both user application, user information like login, email, and name, and then the team. And they're all together in a single context. The problem here is that all the components will have to subscribe to this, regardless if they need only the team or only the user. And so whenever someone changes the team, all the components that also only needed the user, maybe they do not need the team state, will also re-render. This is a huge problem and it can generate performance bottlenecks. Instead of having this, we can apply the single responsibility principle and interface segregation at the same time and split it into two different contexts that different components can subscribe to if they want to. Some components would need both. Some of them might only need the team context, and some of them might only need the user context. Solid principles are nothing abstract. They are things you can apply on everyday code basis. And you do now have some examples you can use in your next coding interview. I'll see you in the next one.